Hello everyone, welcome back to our channel. And in today's video, we are going to solve a new LeetCode problem, and the problem is called linked list cycle. This problem is frequently asked in interviews, and it will test your ability with two pointers and time optimized approach, as well as your ability to tackle linked list problems. So let's go ahead and delve into the problem. In this problem statement, it is said that you are provided with a head, and the head of the linked list determines if the linked list has a cycle in it or not. So basically, you will be provided with a linked list, and you have to see whether there is a cycle in it or not. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. So whenever we traverse through a linked list via its next pointer, right? So 3's next pointer is 2, 2's next pointer is 0. And when you continuously do it, and if there is a cycle, that means if you reach some node which you have already reached earlier, that means there is a cycle. Okay, so that's how you will detect a cycle. Okay, so that's what is an indication of a cycle in a linked list. And this says that internally pose is used to denote the index of the node that tail's next pointer is connected to. Note that pose is not passed as a variable. Okay, this is an extra detail. So finally, what you have to do, you have to return true if there is a cycle in the linked list, otherwise return false. So in overall, your problem statement is that you will be provided a linked list, head of a linked list. Okay, if it has a cycle, then we should return true, and if it doesn't have a cycle, then we should return false. Okay, so that is your overall problem statement. So if it doesn't have a cycle, then it would have been null here, right? So if there was no cycle, then this would not have existed, this link between -4 and 2, and -4 would have pointed to null value, and if traversing to the linked list would have reached to a completion, indicating that there is no linked list, there is no cycle, and hence return false. But whenever there is a cycle, you have to return true. So that's our problem statement, that you have to detect whether there is a cycle in a linked list or not. Okay, so let's discuss the approach now. One common approach to this problem, or the most popular one, is Floyd's Hare and Tortoise algorithm. So what Hare and Tortoise algorithm of Floyd does is, it says that we need to have two pointers, slow pointer and a fast pointer, and we'll make use of this to indicate whether there is a cycle in a linked list or not. So Floyd's Hare and Tortoise algorithm says that fast pointer will move twice the speed of slow. Okay, so what do I mean by that is, if slow pointer moves one step ahead, then fast pointer will move twice step ahead. If slow pointer will move one step ahead, then fast pointer will move twice step ahead. Okay, so it will traverse in that way. So what Floyd's algorithm says that we have two pointers, and we'll keep on traversing both these pointers, okay, until and unless these two pointers meet. Okay, so that's what the overall idea of Floyd's algorithm is. It says that will traverse both slow pointer and fast pointer, and if fast pointer and slow pointer meet at some node, that means there is a cycle. And if it doesn't meet, then and reaches to a completion or have encountered the tail, then that means there is no cycle. But if they meet, then there is a cycle. So let's understand this scenario with an example. So what Floyd's algorithm says is, initially both slow pointer and fast pointer would be pointing to the head of the linked list, and slow pointer will move just once in each iteration, but fast pointer will move twice in a single iteration. Okay, if slow pointer goes here, then fast pointer will move twice, right? So it will move here And what is next of minus 4? Next of minus 4 is 2, right? So it will point here. Similarly, now slow pointer will move one step ahead, pointing to minus 4, and then fast pointer will move twice step ahead, reaching minus 4. And at this point of time, both are pointing to the same node. This indicates that there is a cycle. Hence, we'll return true. Okay. But suppose, for example, we didn't have this link between minus 4, right? And rather minus 4 was pointing to some other node, or maybe we can say it was directly it was the tail and it had reached its end and it was pointing to null. Okay. Suppose there was no cycle. So at that point of time, what would have happened, that like initially fast pointer and slow pointer was in the beginning, and slow pointer would move one step ahead, but fast pointer would move twice speed, and again slow here, then fast pointer would reach the end. Okay. So since fast pointer is moving faster, so if there is no cycle, then it will reach the end faster. So whenever fast reaches null, that means we don't have any cycle. So at that point of time, we will return false. Okay. So that's the overall idea of Floyd's Hare and Tortoise algorithm, or specifically I say fast pointer and slow pointer technique, or a two pointer approach. So let's code this problem. Before moving ahead with the coding, one point we can discuss is that how can we justify that this both first pointer and slow pointer will meet at some node if there is a cycle. So if there is a cycle, can we guarantee that fast pointer and slow pointer will always meet at some node? So to justify this idea, let's consider a cycle. Okay. And in this cycle, so if maybe slow pointer is pointing somewhere here, okay, in some node here, and fast pointer is pointing at some node here. Okay. So, and this is the distance between them. Okay. If between two adjacent nodes the distance is 1, and this one we have considered as d. Okay. So if the distance between them is d, then in each iteration slow pointer will move one step ahead, so it will be d plus 1. Okay. And fast pointer will move two step ahead this side, right? So it will reduce the distance, so it will be minus 2. Okay. And this will result in d minus 1. So in each iteration, this fast pointer comes one step closer towards the slow pointer. Okay. So in this way, in each iteration, they will come one step closer. So in next iteration, it will be d minus 2, and it will go on continue until and unless it becomes d minus d, which is 0. That means they will meet at this point. Okay. So somewhere when slow pointer is moving one step ahead and fast pointer is moving two step ahead, they will it is guaranteed that they will meet at some point in the cycle. Okay. And also one more thing, that this distance can never become more than n, right? If total number of nodes is n, then in the worst case the entire node forms participate in the cycle, right? But that is the worst case. So in that case, the size of our cycle becomes n. Otherwise, it will be all the cycle length will always be smaller than n or equal to n. Okay. So if that is the case, or then we can say that we can guarantee that these will be not more than n times, right? So till the point that both node fast pointer and slow pointer meets, it will not be more than n, correct? So indicating that it will be of O of n time complexity. Okay. Because here you have seen, right? Initially, suppose in the worst case, the distance between them were n. So now, in each iteration, the distance become closer, right? So how many time it can go? It can go till n times. Okay. So it will never be greater than n. So the overall time complexity is also n, and it is guaranteed that they will always meet at some point. Okay. So that's our understanding of the problem. So that is what Floyd's Hare and Tortoise algorithm is. So now let's move ahead with the coding. So initially we had one fast pointer pointing to the head, and we had slow pointer pointing to the head, and we'll run a loop until fast pointer reaches its end. That means if fast pointer reaches the end or the tail, that means we can say that there is no cycle, right? So while fp is not none, or simply we can say that while fp exists, and fp dot next as well, because fast pointer is moving twice, right? So we'll also have to check whether fast pointer is not none, and fast pointer next is also not none. So fp dot next is next also should exist. And if it comes out of the loop, that means we can successfully say that there is no cycle and we can return false. But in other way, like when they are iterating, then we'll move slow pointers slowly, that is only one step ahead, and fast pointer a little bit faster, like fp dot next, and then once again next. And while they are moving, if they meet at any point of time, if slow pointer and fast pointer is pointing to the same node, then we can return true, indicating that there is a cycle. That's what our overall code is. Let's run this code. Cool. Let's submit this. Amazing. We have successfully solved the linked list cycle problem. This problem will really help you in your interview and your understanding of linked list and using two pointer technique. So, and also it will kind of act like a foundation for more advanced topic in the future, like graph or detecting cycles in graph, like that. So this is a very important problem. If you have found this video helpful, then please give it a thumbs up and subscribe to our channel for more coding questions and interview preparation. If you have any doubt or any suggestion, then please put it in the comment box, and don't forget to hit the bell icon so that you can get notification whenever we upload new video. Thank you so much. I'll see you in the next video. Thanks a lot.